Um, sure, Rob. My name is Doug Danforth. I'm an associate professor of obstetrics and gynecology at Ohio State University. I got into Second Life just about a year ago. I was asked by my dean to look at Second Life as a possible avenue for some novel medical education opportunities. And I'm getting something. Is Zay Mu part of your group there?
Yes, he is part of our group,
Oh,
but you can
okay.
ignore him. He's.
All right.
Oh, wait, sorry. One second. What is he telling you, that we have to wait? Is that what he said?
No, I was just afraid he was going to get on the tour and then we were going to be toast.
Oh, okay. Oh, no. Wait, actually, is he up there? He didn't
Yeah,
give me
he's
the...
in front of me. He sent me a URL for a stream.
Okay, no. Tell Z not to do anything. Just stand there. Don't touch anything. And ask him if the stream is ready, right?
Sorry, so at any rate,
Yep.
I got into Second Life to just sort of explore what the educational possibilities were. Excuse me. I teach reproduction to second-year medical students, and one of the topics that we struggle with is an aspect of how the testis functions, and specifically how sperm development occurs in the testis. And it's I've struggled with trying to teach that to both the undergraduates and the medical students for a number of years now. And so I had the idea, once I'd been in Second Life for a couple of months and got my feet wet and looked around, that I might be able to create a simulation in Second Life that would better explain this specific process. And so I began to learn how to build and learned how to script and created an animation that sort of explains the process, and we'll see this animation in a bit. And then once I got that initial piece done, then I thought, well, I could make this more immersive if I just created a simulation of the entire testis. And thus I could bring my students, give them sort of a unique view of the biology, take them on a virtual tour, if you will, through the testis. They can see the major structures in the testis. They can look at the seminiferous tubules where sperm are produced. We can actually go inside a seminiferous tubule, look at the cellular structures, and look to and see how the anatomy and the physiology work together to regulate sperm production. And so I did that for quite a while. And Rob, is Damien with you?
Yep, he's also.
Oh, okay. All right, good.
I don't know where he is. Oh, there he is. Yeah.
So,
he's hiding in the back.
so I spent several months learning how to build on this particular scale and created the simulation that you'll see. And one of my goals with this was to have my students come in and work on this in groups, and then after going through the simulation, sit down and discuss what they saw, either with me or with each other. Because for me, the two most powerful aspects of Second Life are the immersive nature and the fact that you can create unique opportunities to visualize structures that obviously don't exist in the real world, and the ability for people from remote regions to come together in small groups to discuss specific topics for learning opportunities. So I thought maybe those two sort of strengths of Second Life, or unique aspects of Second Life, might be useful for this sort of learning opportunity that I tried to create. So Rob, if you and I want to get on the...
Yep. Just a note for anybody who's out there watching or listening: please don't get on the ride before us or even after us. It could disturb what the doctor is going to try and display. So just stay still.
So are you ready to get on, Rob?
Yeah, go ahead.
Okay, I'll get on first, and then you get on after me.
Oh, well, we wanted that I sit on the right, on the left-hand side, I believe, right?
You should sit on the left.
Right,
So
exactly, that's
I will try to click on the
So you try and
right
click
one, okay, and you click on the other one.
Exactly. Super.
Hey, and it works.
Excellent.
Okay, so we are now going to take this tour vehicle on a tour of the Testis. You'll see text come up that will explain to my students what would be going on, and I'll sort of narrate this as we go. And so you can sort of read along as I narrate, and I'll add some commentary.
Excellent.
So we're gonna go on a tour through the Testis. Right now, we're just flying out to the very corner of the island because the model is so big that it takes up the entire island that we're on. And we're now just basically flying up. You can probably see the platform we were on before. We're now in front of the Testis. And we're looking at the outer covering of the Testis, and that's called the tunica albuginea.
Well, one second, Dr. D. We don't see
Sure.
anything just yet. What are we missing?
There should be a white sort of structure. If you can maybe focus your camera farther away.
Yeah.
It's completely black.
No,
There is something here, but
try turning off midnight and coming back to it. We'll try and turn the midnight on when it's absolutely necessary.
summarize.
No, we don't see.
It's pretty much empty.
We don't see anything. Do you see something? You're with us, right? Do you see?
Yes, I see the particles, the sperm particles. You're not seeing
the
any
sperm
of that?
particles. Yes. So come in a little bit closer. No. And we're not crashed.
And so we should start flying forward pretty soon.
Okay. All right. Yeah. Just stay looking in the front, more or less. Okay. I think
Are we
you're-
flying forward?
Yeah. Okay.
Some-
Now go back to
Okay.
to midnight.
So now, Rob, you're going to want to switch to mouse look at this point because we're going to actually enter this seminiferous tubule.
Yeah. Excellent. We're there.
And we're going to go inside the tubule and see where sperm are produced. And so right now we're in the tubule. Those long things around our head, those are the tails of sperm. And the fluorescent things flying by, those are mature sperm that are making their way down the tubule and getting ready to leave the testis. And so if you look to your left, we're going to follow the path of those sperm. And in a second or two, we'll head that way. And then, so here we go, and now look to your right a little bit. And we will travel down this sort of connecting tunnel to the next part of the model that I built. So we were just in the first part, which is the overview of the testis. And now we're going to be looking at a sort of a higher magnification view of an individual seminiferous tubule. And we are now at the entrance to an individual seminiferous tubule. And we're going to look at the various structures in this tubule. You can switch out of mouse look if you want at this point. Doesn't really matter. But the covering around the outside, this is where I explain to the students what each of these structures are. That's the basal lamina, a basement membrane around the outside. Then underneath that are a specific sperm type called the spermatogonia. And they're going to develop and differentiate into the red cells. Those are primary spermatocytes, and those should be lighting up. Are they lighting up for you, Rob?
Yeah, they are lighting up.
Okay.
It's a little bit dark on the screen, so I'm going to go to noon. Can
And
you tell
so-
us when we need to go back to midnight?
Well, you can stay at noon for a while. And so each of these cells differentiate into the next layer below them. And so the spermatid is the layer that's sort of blue or turquoise, and they're going to mature into a final stage, which is a mature sperm. And those are probably more familiar to the folks in the audience there. Those are what we typically think of as a typical sperm cell. They have a tail and such. These big white cells that just lit up, those are a specialized cell called the Sertoli cell, which nurture the sperm as they develop. Now there's an important piece that just lit up there. Those are red tight junction or connections that connect these Sertoli cells. And those are incredibly important in sperm development, and is one of the reasons why I built this the way I did. so that we can see how those tight connections participate in this process. And so now we're going to enter the tube. You can see the sperm as they leave their stations at the edge, they move to the center of the tubule, and then they go down the tubule and will actually leave the testis to enter the epididymis and the vas deferens outside the testis. An important feature at this point is that these sperm are not swimming. They're only floating down the testis. Sperm don't acquire the ability to swim until they actually get outside of the testis. And that's a topic that I always test the students on. And so now we'll take a tour in between some of these Sertoli cells and sort of take a close look. Mouse look is good for here if you want to switch into mouse look at this point. We're now traveling in between these big Sertoli cells, the cells that nurse the development of the sperm. And in a normal patient, these spaces would be filled with developing sperm, all of those colored balls that we looked at. But there are some conditions, some patients have a condition in which they don't have any of the germ cells, they have only Sertoli cells, and that's a syndrome called Sertoli cell only syndrome. But normally these spaces would be filled with sperm in different stages of development. And so we're just sort of taking a trip through the inside of the tube. Now we're in amongst some of those cells. And now we're going to go outside the tube and look at it from the outside. And hit escape and switch out of mouse look at this point. And we're slowly making our way to our next station here, but we're going to be looking at the tube from outside. Up to this point, we've been inside the tube looking all the time. And we're going to see that all of the blood vessels are actually outside of this tubule. There's another specialized cell type, these yellow gold cells. Those are a cell type called Leydig cells. But the key feature here is that most of the sperm cells, the developing sperm cells, are inside the tubule, but the blood vessels are outside the tubule. So there's a barrier between those two. And it looks like that big white basement membrane should be the ultimate barrier, but in fact it's not. It's the connection, those red connections between the adjacent Sertoli cells that form the ultimate barrier. And I'm going to make the white membrane disappear now, and hopefully you can see that those tall gray Sertoli cells, they're sort of connected by a red border there. And the blue cells are sort of on our side of that border, and all of the other cells are on the other side. They're actually inside. And that's a really important point in this whole process, that these blue cells are outside and the other cells are inside. And we're going to go to an interactive part of the tour which will sort of explain that for us. And at this point we have to get off the tour vehicle because we're going to look at an animation that I created that will explain that process that I just talked about.
Can we get off now?
Yeah, we're off.
Okay, we're off. Okay.
And so we need to kind of walk over. Rob, if you want to walk over a little bit closer to the edge, you don't have to get all the way there. But so what we're going to do now is we're going to look at two Sertoli cells, these two that are in front of us, and that blue spermatogonium up on the top. And we're going to watch how these cells interact with each other to regulate spermatogenesis. And this demonstration is triggered by this sign. So I'm going to touch this sign on the top. And hopefully you can read the one on the right. And it says, in order for spermatogonia, these blue cells, to enter the tubule, they must pass through this barrier, this red barrier called the blood testis barrier. And that blood testis barrier is really important. And so what happens is that this blood testis barrier, these tight junctions, these red things, they must dissolve or they must unzip to allow this blue spermatogonia to get through. And so what you'll see is you'll see these red tight junctions dissolve. Now the spermatogonia can get through, and as soon as it gets through, those tight junctions will reform again. And those tight junctions are the things that keep products of the immune system from attacking these sperm cells. Remember, all the blood supply are outside here, and normally antibodies would come in and attack these developing germ cells because the body would recognize those as foreign. So now that now that it's inside and these germ cells are undergoing a process called meiosis, they're protected from immune attack from the peripheral circulation. So now this is a structure called a primary spermatocyte. It still has all of the chromosomes it's supposed to have, but as it continues to mature into that second structure called the secondary spermatocyte, it undergoes a process called meiosis, which reduces the number of chromosomes by half. It'll continue to mature. It'll undergo a second meiosis, which causes a few more genetic change, reduces the DNA content a little further. And then finally, it undergoes a maturation process where that round cell now looks more like a sperm cell that we're used to seeing. It's got a head, a midpiece, and a tail. And then when that mature sperm now is released into the lumen of the tubule, that has a specific name, we call that spermiation. The sperm is released into the tubule and it floats on downstream like we saw before. And so my students, they go through the demonstration, they learn the initial part, they get off here to see how this process works, and they can go through this as many times as they want. And now, Rob, you and I can go over to the vehicle that's waiting for us over here and get on, and it'll take us back down to the main area. So if you want to just, I'll hop on, you can hop on.
Yep.
And this takes my students now back down to the platform where we started. And down there, I've created a sort of a meeting area or a small gathering area where we sit around this virtual campfire that I created just so that it was kind of fun. And then we can discuss what we just saw. We can use the small group sort of active learning power of Second Life to meet here. And so the students, we can have this class, we can have this demonstration, and we can talk about this. And the students can be anywhere. They don't have to be anywhere really around here. And that's important for our program because we have a segment of students that don't actually live here on campus. It's a distance learning component. It's an independent study program. And so those students don't live here in the city of Columbus. They usually live in Ohio, but they may be 20, 30, 40, 50 miles away. And so we can all get together. We would now then go over and sit here, and we could discuss what we were doing. I have a quiz for them here. That box over to the right is actually a quiz so they can assess their learning. And then I also have some feedback tools so they can provide me feedback as to how this was. Because one of the key things I'm interested in is, was this worth the amount of effort that they had to spend to get here? Yep. Most of my students have never been in Second Life before, and so I had to give them detailed instructions about how to create an account, how to log in, how to go through orientation, and then how to get here. And that, from the feedback I've gotten, has taken them anywhere from 15 minutes, usually about a half an hour, to get through the orientation part. And then it's pretty easy for them to get up here after that. And so what I wanted to assess was whether or not this was worth their time and their trouble. And almost universally, they've said yes. I've had a couple students who struggled with problems, but greater than 90% of the students were able to hear without a problem and thought that this was useful. And I'm encouraged by that because this will only get better as I build the other structures that I need to teach. I will build an ovary so the students can, after they learn the testis function, they can then learn how the ovary works. And then the last thing I'll do is build a simulation of fertilization. So we will have sperm that are created in the testis. We will have eggs that are matured in the ovary, and then I'll build a simulation which will depict how the sperm get to the egg and fertilize the egg, and then the embryo starts to develop. So I think even as I develop more rich content for this, it'll become even more valuable for the student. But I was encouraged that they thought it was worthwhile, even with just this particular model that I've built.
Well, it's very impressive, Doug. I really have to say, seeing it again after I've already seen it before, it still strikes me. I was actually curious about one thing, and that is, have you noticed that having gone through the process, that the difficulty that they didn't get it before, they do now? Have you noticed that more students actually learned something that they couldn't really visualize before?
I'll be able to tell you that after March 7th, because that's when my first group of students will take their final exam, and that's where I will test them on this.
Excellent.
So I will get sort of quantitative data as to whether this helps. I'll be able to compare their understanding of this process this year versus the students I've had in previous years that didn't have this opportunity, and we'll be able to look and see whether or not this was just more than interesting, but actually helped them understand this somewhat difficult concept.
Fantastic.
So I don't have any data yet.
Thank you.
When we.
I don't know. Are there any questions? Does anyone have? Oh, there's a question. Yes. We just have to wait for the microphone. Sorry, Doug. Just
No
one
problem.
second. Yes. Go ahead.
Hi. That was very impressive.
Well, thank you.
How much time and effort did it take you to build this?
I've been working on this off and on for probably a little over 6 months. The first couple of months in Second Life, I was just trying to learn what was possible. And I talked with a lot of people about, this idea. The biggest difficulty is building on this scale. Most of the objects in Second Life are smaller, and so to work with things this large took me some time. So I would say I spent the first month or two just getting my feet wet. And then once I kind of learned the ropes, I tended to work on this over lunch hours. I would, I either teach in the morning or I do research. And so I just decided, all right, every day for an hour or two over lunch, I would build a piece of this or learn about this. And that probably took me 6 months. I will say that the last 2 weeks before class started, I was in Second Life probably much more than maybe 4 to 5 hours a day as I had to pull all this together. I had to move this entire simulation from a different island over to here, and I only had about 2 days or 3 days to do that and get this tour set up. So I think, this probably took me 6 months off and on. I believe I can build an ovary now in probably a month, now that I know how to do these sorts of things. And so, a few hours a day over the course of a month, I think I can put together a pretty good simulation of an ovary.
Fantastic. Are there any other questions? One more. Jeroen? This is one from Second Life, I believe. Is that right?
Yes, that's right. Arden Vos asked, he was earlier actually today, but he had to leave, but he's now on Second Life.
Right.
He asked, what did the students think about the communications part? How did you feel about communication in Second Life? And
Could you hear that?
Yes, I did.
Yeah.
For the most part, it's been pretty good. I was nervous or worried about the fact that, for the longest time and for most of my tenure in Second Life, communication has been via text. And I'm of the generation that is not used to instant messaging and typing in chat, and so I saw that as a big limitation. The students tend not to see that as big of a problem. They're used to sending instant messages and carrying on multiple chat text conversations, and so not a single student mentioned that as a limitation. I personally see it as difficult, and as I will say though that most of this initial experience for the students was focused on getting them through the tour so they could understand the concept, and less emphasis on what we're doing right now, sitting around. I certainly did that with a number of students. But what we're doing now in terms of sitting around discussing will become a greater component of this, because I think this is an important part. And I plan on using a combination of text and voice. I probably will be in the format that the format that works the best for me is for me to use voice to speak to them, and then they can either use voice or type chat messages to speak with me. But in terms of communication, I didn't get actually a single comment that, typing to talk was a pain in the neck or difficult or a limitation.
Okay, well, thanks very much. We've run out of time. We have to move on, I'm sorry, unless it's...
Okay.
No. Okay. Dr. Doug, thank you very much. It was, again, really, I think most of the people here were pretty impressed. I certainly was, again. So, thank you.
Sure.
Appreciate
Thank
it.
you. See you soon, Rob.
Okay, talk to you.